I accidentally deleted the first half of my video I made for horizontal launch problem, so I'm just going to go through my work and instead of redoing the whole thing, I'm just going to explain it as I go. So this week we're going to do horizontal launch in 2 dimensions. We're going to use our kinematics. So for our horizontal direction and our vertical direction, that motion is separate from one another. So we're going to keep our variables separate for the horizontal and vertical. You can use your kinematics in both the horizontal and the vertical direction. But since there's no acceleration in the horizontal direction, your equation becomes x is v times t. And for horizontal launch problems specifically, there's no initial velocity in the vertical. So your equation becomes this. We can do this for the other kinematics. For our other kinematic, right, we can cross off acceleration. This is not super useful in the horizontal because our final is equal to our initial. This doesn't really tell us anything. And this one is still useful in the vertical direction. It's going to be our final velocity is equal to our acceleration times time. And the last equation, right, is not helpful in the horizontal, right? Our initial velocity squared is equal to our final velocity squared. This is not going to yield us any new information, but we can use this equation in the vertical direction. My final velocity squared is going to be equal to 2 times my acceleration times my displacement. So I set up an initial problem, number 1, that's on your work for today. So the problem says an object has an initial velocity of 8 meters per second. When the question is asking for when the question says I have an initial velocity, it is implied that it is in the horizontal direction if you're doing a horizontal launch. So if you read the question, it says an initial velocity of whatever it is, it's referring to the velocity in the horizontal direction. The word problem also gave me a height of a cliff of 122.5. So this was the 2 pieces of information that was given to me in my word problem. So similar to how we set up our list of variables, we now have 2 lists of variables. We have variables in the x direction, variables in the y direction. We were given an initial velocity always of 0 in the vertical. Your acceleration is always going to be negative 9.8. Your displacement here, I went from a higher position to a lower position, so my displacement's going to be negative. These 3 were given to me in the word problem. Well, just this one, right? But we can always rely on our acceleration being negative 9.8 and our initial velocity being 0 for a horizontal launch scenario. This is very similar to an object being dropped in one-dimensional motion. We were also given our initial velocity, but we were not given our displacement or our time. So we have enough information here to solve for our time. Time is the same in both directions, and we need to generally solve for time first before solving for whatever the question asks. So the question asks, what's my horizontal displacement? Right, but without my time, right, I don't have enough information to find my horizontal displacement. So I'm going to use the variables in the y to find my time. Using this equation, because I have my displacement, I know my acceleration. Rearranging my equation gives me a time of 5 seconds when I plug in all my variables. Right, your time should never be negative, and you should never be square rooting a negative number. So oftentimes I'll see students not putting a negative on their displacement, but for an object that's being launched horizontally and going down, our displacement in the vertical is always going to be negative. So we figured out our time of 5 seconds. I added that to my chart here, and I added it to this side here because time is the only variable that is the same in both directions. Your other variables are independent of one another. With our time, we have enough information to find my displacement. Using this first kinematic up here, I just copied it down here and plugged in my numbers to give me 40 meters. This is my horizontal displacement, my displacement in the x direction. The second question asks, what's the final velocity in the vertical direction? So I used my equations for the vertical. I know my time now, which is 5 seconds, and my acceleration is implied at negative 9.8. So I got a negative 49. Your velocity in the vertical will always be negative because you're going from some higher position to some lower position. So my final velocity here in the vertical is going to be 49. The last question asks, what's the total velocity of this object before it hits the ground? So bringing in our vector addition from last week, we have a vector that is horizontal, 8 meters per second, and we have a vector that is vertical at negative 49 meters per second. Right, now I'm going to use Pythagorean theorem to find what my resultant vector is, my total velocity. Right, a squared plus b squared equals my hypotenuse. In this case, my hypotenuse represents the total velocity of my object right before it hits the ground. So I plug in my numbers and I find that the total velocity is going to be 49.56 meters per second. I didn't initially find the direction of my velocity, right? Because velocity is a vector, so this is the magnitude. And if you wanted to find the direction, you could use the trig functions, sine, cosine, or tangent, because now we have all three legs of our triangle. And the second video I'm going to post is on question number 3, which looks for an initial velocity.